We'd now like to investigate one of the more interesting properties of lists, and that is the ability to modify an item of the list. Remember that strings are sequences of characters, but they are immutable. That is, we are not allowed to modify a character within a string. If I try to do that, for example, if my name is a reference to the string DAVID, I can certainly access the character at position 2, but if I attempt to modify through assignment that position, say make it equal to the string Z, I get an error that strings do not support assignment by item. This is not the case for lists, however. A list can allow item assignment in the same way that we do other kinds of assignment. So for example, if my list is the list consisting of, let's say, 2, 6, and maybe a Boolean false. So we have a 3-item list. I can certainly access the second item in the list, the item at position 1, and that's the value 6. But now, what I can also do is have that appear on the left-hand side of an assignment statement, and maybe I can replace that with the string cat. If I do that and look at my list, what we see then is that my list now has 3 items, but the second item in the list is now the string cat, whereas originally it was the integer 6. And just to be sure, we can go ahead and access that item once again, and we see that it is now a string. Now the question is, how does this work? Why is this possible? Well, in order to see that, let's take a look at a diagram. So if we think about my list as being a reference to the list containing 2, 6, and false, the original list, then what we really have is a collection, and we could draw this collection as 3 positions. The first position is the 0 position, the second is the 1 position, and the third is the 2 position. My list is a collection of 3 positions where each of those positions is actually a reference to an object. So for example, the object 2 is in the first position. The object 6 is in the second position, and the object false is in the third position. So my list is a collection of references to objects. What this means then is that if I try to access my list indexed by 1, what that says is to give me the object that is referred to by my list indexed by 1. But because this reference is something that we can modify through simple assignment, when I say my list indexed at position 1 will be a reference to the string cat, well, what happens is, first of all, the string cat, which is an object, appears, and then the reference from my list indexed by 1, this reference is modified so that now it refers down to that new string object. So what we say is that lists are mutable. That is, lists can be modified item by item. Of course, we could modify the entire list through assignment, but in this case, by simply modifying a single item of the list, we can change the makeup of that list. This is something we cannot do with strings. Strings are immutable sequential collections of characters. Lists are mutable collections of any kind of Python data object.